So I want to take a look at some stuff regarding fractions. So if you look at a kind of a classic egg carton right here, I would ask you in class, how many pieces is this divided up into? Okay, and so if you just count them up, there's 12 of them. There's 12 pieces. It's a dozen eggs, so 12. So you could look at it as a space that's been divided up into 12. Well, what I want to do is think about this. What if I cut it right there? Okay, so the rest of this is gone. Okay, then I've got 4/12 of this egg carton still sitting there, right? Well, yes, except I want you to notice something. I'm actually going to cut it right here. Okay, cut it right down the side here. Okay, so I've got 4/12, but I want you to notice that this is the same size as if I cut this piece. Okay, so here's 4/12, here's 4/12, and here's 4/12, but notice that they're the same size. Okay, so each of these spaces is actually 1/3 of the whole dozen. Okay, so 4/12 is the same thing as 1/3. Well, I could look at it this way too. I could cut this one in half. Okay, so there you go. Here's 2/12. Okay, but that's the same size as this one, and if I cut this one in half and this one in half, I could stack them all up. I'd have 6 equal pieces, and so this would be 1/6. So what we've seen visually is that if you have a whole thing here, you can cut it up into 4/12, but each of those 4/12 is equivalent to 1/3, and you could cut it into 2/12, and each of those is equivalent to 1/6. So we're gonna write that on the screen here. Okay, so what we said was 1/12 was equal to, 4/12 was equal to 1/3, which was equal to 2/6. Okay, what we're talking about here is what we call equivalent fractions. Whoops, maybe I should spell it right. Fractions. Okay. So each of these fractions is equivalent to the other. And what we're going to be doing is spending a bit of time looking at how do you tell whether two fractions are equivalent, or how do you make one fraction equivalent to another one. Okay, so we said that 1/3 was equivalent to 4/12. Okay, well, what would I do if I didn't know how many 12ths this was? Okay, well, I could cut up some egg cartons, or I could say, look, to make 3 into 12, you'd multiply it by 4, right? Okay. So multiply that by 4. Well, what I'll do is I'll also multiply the top by 4. Okay? Now, you might say, Mr. Neckham, you can't go pulling off magic like that. You can't just go making up stuff. You're right, I can't. So let me show you why I can do that. Would you agree that I could multiply 1/3 by 1 and it would remain equivalent? Okay, so 1/3 times 1 is still 1/3. Well, what I'm doing when I multiply by 4 on top and 4 on the bottom is really I'm doing this. I'm multiplying by 4/4. And that, my friends, is the same thing as 1. Okay, it's equal to 1. So when I multiply by 4/4, or multiply by 4 on top and 4 on the bottom, okay, I'm not breaking any rules. I get 12 down here, and I get 4 there. Okay, so if I give you some fraction 3/5, and I say, would you please find out what equivalent fraction has the denominator of 15, okay, you'd say, oh, I know. If I multiply this by 3, I'd get 15, so I'll multiply the top by 3 and get 9. Okay, well, in the textbook that we use and lots of other textbooks, you'll see examples that look kind of like this. Here is a pie. Let's say it's a banana cream pie, and a quarter of it has been eaten already, so there's 3/4 left. So I'm going to write that. There's 3/4 left. Okay? And you could think of it this way. If you had 3 friends there still, then each person could get 1/4 of the pie. Okay? Because you could say, well, friend 1, friend 2, and friend 3 all get 3/4 of the pie. Well, I would like to be able to divide this 3/4 of the pie up among 9 friends, not 3 of them. So I'd like this golden part to be divided up into 9 pieces, not just 3. So here's what I'm going to do. I'm going to say, how about if I take this piece and divide it that way? And let's assume I can divide these evenly. Okay. So now 3/4 okay, has been divided up into 9 equal pieces. Okay. And here's the question. How much of a pie is each of these people going to get? Well, if you extended these lines out back across here, okay, roughly, okay, there would be 12 equal pieces. So what we're saying is that 3/4 is the equivalent of 9/12. So 9 people would get 1/12 of the pie if 3 people could get 1/4 of the pie. So what we're doing is working on doing equivalent fractions. Okay? So the basic idea is going to be this. In some cases, I'm going to say, hey, here's a fraction, and I would like you to write me a new fraction that's got a numerator of, say, 7. Okay? So what should the denominator be so that I get an equivalent fraction? Well, what did I multiply 1 by to get 7? 7. So I better multiply 4 by 7 as well. So I'm going to multiply by 7 on top and 7 on the bottom, and that gets me 28. So an equivalent fraction for 1/4 is 7/28. Okay? Another question we might ask could be, hey, write your own fraction that's equivalent to that. Okay? So what you would do is decide, hey, what do I want to multiply by? 2, 3, 5, whatever it is. If you choose to multiply the top and the bottom by 6, not a problem. You're going to get 30/48. Okay? And the last question we're going to ask you is this. Is it true that this fraction and that fraction are equivalent? Okay? So what you do is check. What did you multiply 5 by to get 15, for instance? 3. If you multiply 2 by 3, do you get 9? No. So in my class, I would say, survey says, they're not equivalent. Okay? So there's kind of 3 types of questions that you'll see there. Okay? That's an introduction to equivalent fractions.